Hello everyone, let's take a look at this question. A research group investigates the safety and toxicity profile of a new drug. Data about the length of time from administration of the drug until the onset of adverse effects is collected for a period of 20 days. Administration of the drug is terminated for any patient experiencing adverse effects. The data collected is shown. Which of the following statements about the data set is most accurate? We see here they have given us a histogram on the x-axis of which they have plotted treatment duration and on the y-axis the number of patients. Now the thing that is standing out in this data set is that it has asymmetrical distribution. This is not the normal Gaussian distribution. So the normal distribution looks something like this, but we can see that the distribution here, it looks something like this. Like there is a long tail like structure here. There is a tail on the positive direction of the scale. So this histogram is basically showing asymmetrical distribution, positively skewed distribution, because there is a tail pointing on the positive direction of the scale. They are asking us which of these statements is correct. The data set follows a right skewed distribution, normal distribution, the median is greater than the mean and mode are equal, the data set follows a bimodal distribution, the data set follows a left skewed distribution. So let's take a look at this option here. The data set follows a left skewed distribution. Now if the data set was following a left skewed distribution, the cluster would be on the right side. Like most of the data would be here, like on the right side, and there would be a tail on the left side. When we say the data is skewed in a particular direction, we mean to say that the tail is on that side. So it would look something like this, but our data does not look like this, right? It's the exact opposite of that, in fact. So this statement is not correct. Then next we have the data set follows a bimodal distribution. It would have bimodal distribution if it was, let's say, had two peaks like this. Then we would say that it has a bimodal distribution. There would be two peaks within the histogram. This happens when there are two groups within the study population. But this data clearly has got like a left-sided peak. Now before we move any further, we need to take a look at the measures of central tendency, which are the mean, median and the mode. Now mean is like the average. Let's say there are 4 values given to us. We'll add those 4 values, divided by 4, and that's our mean. It's like an average. Then we have median. What is median? If we arrange our data from like in an ascending order or a descending order, the middle value will become the median, right? Then finally we have the mode. The mode is the value which occurs the most times. Now on this figure here we can see 3 different types of distributions. We have a symmetrical distribution, we have a positive skew, and we have a negative skew. If you look at the symmetrical distribution, the normal distribution, Gaussian curve, we can see that the mean, the median and the mode, the 3 measures of central tendency are the same in symmetrical distribution. They are all same here. Whereas if you see this curve, the positive skew curve, you will find that mode, it's very easy for us to understand the concept of mode. It's the number occurring the most times, right? So at the peak, like wherever the peak will be there, our mode will be. So at the peak we get the mode. Then if you look at the x-axis and find its central point, there we'll find our median, and finally mean is like the average. Whenever we have an outlier, like there is a value, like the data set was 5, 6, 7, 8, and all of a sudden you get a 250. So that's an outlier. That value 250 is an outlier. Now mean is the value that is most affected by the outliers. Then we can see the negative skew also. So just keep in mind, at the peak we'll have the mode, then we're going to have the median, because it's like the middle value when the data is arranged in a ascending or descending order, and mean is like the average value. Now let's come back and take a look at this question again. The mean and mode for this question are equal. No, it is not a normal distribution. So the mean and mode cannot be equal. So this is incorrect. The median is greater than the mean. So the median is greater than the mean. Let's see. We are going to have the mode here, the median, and then the mean. So mean is so far along the x-axis. The mean, the value is coming here, like let's say around 14. The median value is coming here, it's going to be around like 10, and the mode here is going to be 6, right? So is the median greater than the mean? Median, is it greater than the mean? No, it's going to be around 10. This one here is going to be around 14. So no, the mean is greater than the median. The mean value will be greater than the median. The data set follows a normal distribution. It clearly does not follow a normal distribution. The data set follows a right skewed distribution. Yes, the data set does follow a right skewed distribution because we have a long tail, just like we discussed. Wherever the tail goes, in that direction the data is skewed. So the tail here is on the right side. So it is right skewed distribution. And that's all that we had to know in this question. Thank you so much.